let's talk about a little more information on how to determine the dependent and independent variables, the domain and range, and how to show that information on a graph. So if we're looking at our example of our dive into the ocean and different pressures that we might experience, we're given this function P of D equals 0.4455D plus 14.7. D is the depth in feet and P is the pressure in PSIs. So if we look at this initial function notation, we can use that, P of D, and we can use that to help us determine. It's always going to look like this: dependent by independent. And so then that tells us that that D has to be our independent and the P has to be our dependent. So we can say independent has to be the D, which is the depth in feet. Now it's important to list the units with the variables, otherwise they don't make a whole lot of sense. We don't know inches, meters, feet, miles, kilometers, or what. And then our dependent is going to be the P, which stands for pressure, and that one's in PSIs. Okay, and when we're looking at the relationship between the quantities, we can always think of it as dependent by independent. And you can see it's the same order as I was showing for the function notation, so that's helpful. You don't have to change orders at all. Dependent by independent, and when you're writing it out, dependent by independent. And so we want to sometimes add a little bit of extra information. This one, the dependent variable was the pressure, so we could say pressure by depth. And the little extra information I would want to put on this title would be depth into the ocean, because we're talking about going down into the ocean and how the pressure increases. Okay, and a domain for the function. For domain, we are always, domain is always for the independent variable. And so we're looking at the smallest value possible to the largest. And then we put some symbols, and it just is going to vary which one we use depending on what our value is and whether it's included or not. So the smallest value that our independent variable could have, our independent variable we can see there is our depth. So what is the smallest depth that we could have? And the smallest depth is 0 feet into the ocean, and that's you floating on the surface of the ocean. And you could actually do that. So the smallest depth would be 0. And then the largest value for the depth, we're not sure how deep the ocean is, so we'd have to put infinity, because we can we know it doesn't go all the way to infinity on and on, but we don't know where it does end, so we'll just give it infinity. And then when we go to graph, remember this pressure by depth into the ocean, the answer for part B, that was our dependent by independent with a little bit of extra information, and so that becomes pressure by depth into the ocean. And then when we're graphing even further, on the left-hand side, that is going to be our dependent and independent on the right variables. And so you can still think of it as over here as you look left to right, it's still going to be dependent by independent, dependent by independent, dependent by independent, and in the function notation, dependent, parentheses, independent. So always in that order, dependent by independent, dependent by independent. Are you getting it? Okay. So dependent by independent as you go left to right. And so that might help you just a little bit. Then we want to look at what was our dependent variable again. Come back up here where we wrote it. Dependent was pressure in PSI. We want to put all of that onto our label. So here we would write pressure in PSIs. And then independent for this one was depth. So this one would be depth in feet. Now the goal with your labels is for your graph all by itself to tell the whole story about your scenario. So if I didn't put into the ocean here, then it'd be pressure by depth. I wouldn't know, are we digging into rock? Are we in the ocean? Are we in outer space? Are we talking about depth into a beaker? I mean, it's hard to tell. So if I say depth into ocean, then I have a better idea. And then when I look down at the label at the bottom, depth in feet, then I know how many feet down I'm going. And then we're talking about pressure in PSIs. So that helps me get the whole story for what we're talking about in this scenario. Now, just as before, we're going to create an XY table, and we're looking at depth here. And remember, that's our independent variable, and it is in feet. And I might just want to put the word depth there to help me remember. And then the P of D altogether, that notation, is the same thing as the P, which is the pressure. And so then when I plug in some values for D, I can use them to help me graph. And I'm going to look at that a little bit more on the next problem. But remember, we're going to look at the 85 and the 15 and make sure that I include those on my graph.